Hey everybody, welcome back. Well, today I'll be talking about the kinetic energy, right? So, what is kinetic energy? Kinetic energy is the energy possessed by a body due to its motion, right? So, let's say, so now we will derive the expression. You might have heard the expression that kinetic energy is half mv square. How do you derive this? Where is this expression half m into v square coming from? Let us derive it. So, for all these derivations, we are using the same basic concept which we have discussed in the previous videos, that energy is nothing but work done. What work done is nothing but the energy, right? So work is converting into energy is converting into work done, right? So let's say I have this body has a mass of m and it is moving with velocity v, and now I need to calculate what is the energy possessed by a body due to its motion, because that is the kinetic energy, and I want to calculate the expression for kinetic energy, right? So what I will do is, I know that this energy I have to calculate, right? So how do I approach this? I say that, fine, okay, fine, this body has some energy because of its motion, and that is the kinetic energy. What if I bring this body to complete rest? If I bring this body to complete rest, now what is the energy? Zero, right? There is no energy, right? So I see a method to calculate that. Okay, fine, now initially the body is moving with some velocity, and if I could bring this body to rest, there would be that energy would be converting to zero. And for bringing this body to rest, I will have to do some work done, right? So if I have to stop this body, I'll have to do some work, external work. And work done is easier to calculate because that is nothing but force into displacement, right? So now I get into this approach for calculating the kinetic energy expression, that if I calculate the work done for bringing this body to rest, I will have the expression for kinetic energy, right? So let us do that. Let's say this body is moving with the velocity u, correct? Now I apply some force in the opposite direction, so that there is a negative acceleration or the retardation which is happening, and finally the body comes to rest, right? And what would that force be? That force would be mass into acceleration, right? So now I need to calculate the work done, or the magnitude of the work done. And what would that work done be? Force into displacement. What is that displacement? The displacement, the distance moved by the body is when its velocity becomes zero. So initially u till final zero, what is the distance in between them? That is the distance. So force is nothing but mass into acceleration multiplied by displacement. We are already familiar with all the three equations of motion. So I have the initial velocity, which is u. The final velocity is zero, right? And I need to calculate the displacement, and I already have the acceleration, which is a. Which equation of motion should we use? The third equation of motion, that says v square is equal to u square plus 2as, right? So v is the final velocity, u is the initial velocity, a is the acceleration. And since this is a retardation, I will write a as minus a, right? So we have final velocity as 0. So if you put all the values, you get on the left hand side, you get 0. Here you have u square minus 2as. From here you can see that the displacement will come out to be u square divided by 2a. This is my displacement. And now I want to calculate the work done, which is nothing but force into displacement, correct? Force was mass into acceleration multiplied by displacement. And what was displacement? U square by 2a. Can you imagine it in your head? Acceleration and acceleration cancels out. You are left with half mu square. So suddenly we have an expression for kinetic energy, that is half m into velocity square, and that is what we write, right? Kinetic energy is nothing but half mv square, correct? So this is how this expression is derived. In the next video, we'll be deriving the relation between kinetic energy and momentum. All these are useful relations when you are solving the questions, right? So please revise all these videos, and please make notes. And these small videos are a quick revision for you also, and it gives you a basic concepts of how these expressions they are coming from. Thank you so much. Please subscribe to our channel. Bye bye and take care.